Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mask coder this side. Welcome to yet another lecture of binary tree. Right now, what does the problem say? The problem today is invert binary tree. Binary tree. Now, how will you solve this? The problem says that given the tree, you can see that there is a tree here, right? Now, you want to invert it. What do I mean by invert is? Invert means left becomes right and right becomes left. Right becomes left. That is suppose like that is means swapping. It is nothing more than swapping. So if I try to do that, what does it mean? So 4 will remain as it is. 4's left is 2, 4's right is 7 in the original tree. But in the new tree, 4's left will be 7 and 4's right will be 2. Okay, moving on. 2 has children as 1 and 3. So 1 is at left, but it will become right. So 2's right is now gonna be 1. 2's right is 3, so it will be left. 7's right is 9, it will be left. 7's left is 6, it will be right now. Now 9's left is 8, so 9's right will be 8 now. And 9's left is right, 9's right is null, so it will left will be null now. So you can see this tree get converted into this tree. And I have to do it in place. I have to do it in place. What do I mean by in place? I do not have to create a new tree. This is not a new tree. Not a new tree. This is the exact same tree which have been reshuffled, which have been reordered, right? Okay, so memory addresses are same. I just have to reorder. How will I do it? How will I do it? So first hint is binary tree. Whenever you see the word binary tree, understand it has something related to traversal. Mostly it has related something to traversal. Second thing, the second hint given to you is in the question itself, that is swap. How will you do it? Just combine this with this, traversal and swap. What do I mean by that? So for the given tree, you are here at 4, right? Write 4 as it is and swap. What do I swap? The left and the right. The left and the right. What is the left? 2. Right is 7. Swap the whole trees. After swapping, the trees will look something like 7, 2. But because of swapping, 6, 9 and 8 will remain as it is, and 2, 1 and 3 are as it is. So you can see the upper portion, this portion is exactly similar right now. I just have to shuffle this portion as well. What will I do? Traversal. There comes the traversal. So I've just swapped this, coming to roots left, coming to roots left. But roots left was 2, now it is 7. I don't care, I just have to swap. So I will come here, I will see that this is not null, I will swap it. So after swapping, the tree becomes something like this. 4, 7 remain as it is. Because I swapped 7, it will be 9, 6 and 9 will get 8. Right? 9 will get 8. Moving on. 2. In the next iteration, like 2 is obviously here, 2 with 1 and 3. This left will call its left. That is this one. Right? That is left's left. Okay. So like you are understanding, right? Firstly I change this node, then this was called, then 7's 9 is called, then 7's 9 is called, sorry, then 7's 9 is called. If after swapping, which will become something like 4, 7, 2, 9 is called, so 9's children will be swapped, 8 will come at the right side, 7, 6, 2, 3, right? After swapping 9, I will go towards 8. Because I'm following the pre-order traversal, I'm following the pre-order traversal. You can use anyone, you can use anyone. Any one of them will work. But I'm choosing pre-order because I find it the simplest. I find it like it is crammed by the back of the hand, right? Coming to 8. Coming to 8. 8 doesn't have a left or right, so null will remain null. So this recursion call ends, and coming back to 6. This 6. After swapping 6, 6 is also doesn't have null. So it will also no change in the binary tree. Coming to 2 now. So 4, 7, 9, 8, 6. Coming to 2. 2 was initially 1, 3, but it now will be 3, 1. And you can see the answers exactly match. This blue colored answer is exactly matching with this white answer, right? Which is done just by combining two things. What are the two things? The first hint was binary tree, which gave us the traversal, and second thing was swap, which was given in the question itself. What will the code look like? What will the code look like? So you have to decide with me with the code. Suppose the function's name is ref. I have given root. Now because it is a recursion function, what will I do? If root is equals to null, do not do anything, just return. Just return. Otherwise, if root is not null, then what will you do? First, swap the values. Swap root left with root right. Right? Because I'm using the pre-order, so I swapped first. If you are using in order, you will swap in between. If you are using post order, you will swap at last. Right? Then I will call for root left. The same function for root left to swap the values of the left subtree as well. And the function for root right to swap the values for the right subtree as well. At last, you can return your root. You can return your root, which will be exactly same. What is the time complexity? The same required for the traversal, which is O of n. What is the space complexity? O of 1. We are using recursion stack space, but that is not accommodable, right? So O of 1 plus recursion stack space, you can see recursion stack space, which will be accordingly log n, I guess. It will be maximum log n, right? But I'm not sure of it, right? Okay. Now it is time for us to move to the coding area. So here is the coding area, but before starting with the code, I would like to request you to please subscribe to my channel if you are new here, and do not forget to hit the like button, because it's a sincere request. It really motivates me when the number goes up. It really motivates me to make good and more quality content, right? Okay. Now moving forward, what will I do? The first step is if root equals to null. That is the base case, right? In that case, return root as it is. You can return null as well. That will be the one and the same thing. Otherwise, first case, because we are using pre-order, so we will be doing the root first. So swap the root left with the root right, with the root right. And now call the same function invert tree for root left. This is a recursion function, right? And then call the function for root right. See, tree node will be actually returning something, but I don't want that, because I just want to return the left subtrees, because I've already swapped the values, right? So I don't want this value, so I'm not collecting it, right? And you can simply return your root after the swapping. Let us try to compile and run it. Should work fine, I guess. Okay, it is running fine for the sample test cases. Let's try it for the hidden test cases as well. Should not give any error. It is running fine, and it is beating 100% also actually. So thank you for watching, and we'll meet again in the next lecture. Till then, stay tuned and keep coding. Thank you. Have a nice day.